if we're given that the acceleration is constant in any situation, well, let's just write it down here. Constant acceleration implies that v dt is constant and equal to a, which implies that v of t equals v of 0 plus at. And then this implies, well, dx dt equals v. This implies that x of t equals x of 0 plus v of 0 times t plus 1/2 a t squared. So we know this. So if you're given the acceleration is uniform, you know both of these, and you know the other two equations of motion, uniformly accelerated motion, that follow from these. Okay, well, if you're given that acceleration is 2.4 centimeters per second squared, then you know the acceleration here and here. Okay, now if, for example, you're given that when t equals 0, the velocity is -6 centimeters per second, well, you know what your velocity function of t is. Okay? You know the acceleration, and you're given the time at which this acceleration occurs. And actually, I said when t equals 0, let's be a little more general. When t equals, let's say, 3 seconds, v is this. Okay? Because you can give any time, it doesn't have to be 0. Okay, when t is 3 seconds, then we know that t is 3 seconds. This is it's -6 centimeters per second. We know the acceleration, so we can easily find v of 0. Then we have our equation for v of t. So first of all, well, yeah, we can do this. V of 6, V of 3 seconds, messing this up, equals -6 centimeters per second, which means that -6 centimeters per second equals V of 0 plus acceleration times t, which is t is 3 seconds. 2.4 centimeters per second squared times 3 seconds. So -6, well, we can solve then for v of 0. 2.4 times 3 is 7.2. We subtract that from both sides, 7.2 centimeters per second. We do this multiplication. That's what you ended up with. And you end up with -13.2 centimeters per second. Thus, v of t equals -13.2 centimeters per second. That's your v of 0, plus at, which is 2.4 centimeters per second squared times t. Now you see a problem, and if you see this much, then you know, if you do a few problems of this nature, that you can determine v of 0. If you were asked something about the position, you would have to have more information. You have to have enough information to figure out x of 0. If the problem then asks, what's the velocity at t equals 10 seconds, you can answer it. You've got your function here, you just plug in 10 seconds. That's v of 10 seconds. That's going to be 10.8 centimeters per second, I believe. Okay? So, you just evaluate v of 10 seconds. Okay, what if we want to find out when is the velocity 100 centimeters per second? What do? Well, we simply write this as an equation. V of t should now be 100 centimeters per second. Well, here's your V of t. So you solve negative 13.2 centimeters per second plus 2.4 centimeters per second squared times t equals 100 centimeters per second. That one unknown t you can easily solve. Okay, another problem gives you the velocity at two different times, 2 centimeters per second at t equals 5 seconds, 2 meters per second, 8 meters per second at t equals 10 seconds. Well, we can say, okay, that v of t is what it is. V of 5 seconds equals v of 0 plus at. And v of 10 seconds equals v of 0. And it's at, it's a times 5 seconds. V of 0 equals a. V of 10 seconds is v of 0 plus a times 10 seconds. Okay. So what can we do with this? Well, this is two simultaneous equations, and you have two unknowns, v of 0 and a. You can solve this equation very easily. The easiest way to solve it, I would think, and I have completed the equation, fix that. We're given that v of 5 seconds is 2 meters per second, and this is 8 meters per second. So we have this information. We don't need this. Our simultaneous equations are here. If we, for example, subtract the first equation from the second, we get a times 10 seconds minus a times 5 seconds equals 6 meters per second. And this is not a of 10 seconds, it's not a function. A is not a function of time, a is constant, so let's see. Put down the condition that we have uniform acceleration. So we can easily solve this equation for a. Then we plug that into either equation up here, and then we check. So, very straightforward way to solve a problem of this nature.